My name is Ville Tulos. I'm CEO co-founder here at Outerbounds, where obviously, like many of you may know, that this company was kind of like started based on the project we started at Netflix called Metaflow that very much helps you to run AI, ML data projects at scale, like build end-to-end AI, ML applications. And of course, a big part of those systems is always data. And today we are here to talk about our Snowflake integration, which is actually something that's super practical. So, there are webinars that talk about something more futuristic, maybe AI agents or like kind of something that might be relevant, I don't know, like 2 years from now or 3 years from now. And then there are topics that are exactly relevant today and you can start using right away. And this is definitely one of those topics. We have actually many customers. I would even say most of our customers, like maybe slightly over half, are using Snowflake today. So this is also something that has been like battle hardened now for like actually a good amount of time already. And Eddie, do you want to introduce yourself so we can get
Yeah,
started properly?
this is Eddie Matea. I'm a data scientist at Outerbounds. I've been the team for just over 3 years. We've been working in the ML ops space for the better part of the last decade. I use Snowflake a lot, both before Outerbounds and also now in my day job. So I'm quite excited to kind of explore some of these patterns and formalize some of the cool stuff we've seen our customers doing with Snowflake on Outerbounds.
Cool. Awesome. And by the way, like, yeah, we will be switching back and forth like between Eddie and myself. Hopefully, keep this engaging, interesting. And Eddie, by the way, like, if you can keep eye on the chat, like while I'm talking, I'll do the vice versa, like while you're talking, so we can make sure that we will answer any questions on the fly.
Yeah, definitely.
Thank you. So now, by the way, for like everybody listening here, so we did publish a blog post about this topic recently. Here's the URL. You can also like just go to the outerbounds.com/blog, and like I think it's still the top element there, so you can find that easily. And also like kind of accompanying that blog post, like we do have a code samples here in a public repo. So like if you like want to take a look like what actually happens behind the scenes, like you can check out that repo as well. Now, since I know that like all of you are taking precious time to kind of stay with us in this webinar, I definitely wanted to start by motivating a bit that, okay, I mean, like, why should any of you care about anything that we are about to say, and like, what is kind of the point of like doing like what we are doing, and really the motivation. So now, I mean, to maybe state the obvious here, Snowflake is an excellent data warehouse. I think like most of us, most companies need some place where they can put structured data. Of course, there are many choices, have been always many choices, but I mean, like it's just like a Snowflake is a nice product. It's obviously like an enterprise grade. I mean, many companies are very comfortable like using that as the kind of a master data record. So that is great. But now the other side of the question is that oftentimes, besides having a kind of a warehouse for your structured data, you also like have all kinds of other compute needs. And of course, as you know, Snowflake has been expanding their kind of like a compute offering. So that like technically you can run all kinds of workloads on Snowflake. And of course, like many of you know that this is something that Databricks has been doing for the longest time. So that's of course the big kind of a clash of the titans that's going. But it is a fact that when it comes to running arbitrary code on Snowflake, it is an exceptionally expensive first. I mean, it is a fact that like it runs on the same cloud resources that you could as well access directly. And also like it has all kinds of limitations, which is totally understandable that when you are operating a data warehouse, of course, I mean, it kind of needs to come with certain limitations when it comes to dependency management, when it comes to the hardware that's available, when it comes to the ways how you can configure the instances. So kind of that's like really like a big motivation here that I'm sure that like most of you wouldn't like run like all of your business inside Snowflake anyways. I mean, like that's a great data warehouse. Let's use it as such. But then there's the question that like, how do we do everything else? And now, like talking about everything else, here the point number two is that, of course, like when it comes to SQL, many of us need a way to run SQL at scale. And again, Snowflake is really good at that. But there are many other workloads that, let's say, are written in Python. Now, I mean, technically you could use other languages as well. But I mean, when it comes to especially ML and AI these days, I mean, Python is absolutely the dominant language. So we are like a quite Python focused in this presentation, although infrastructure wise, I mean, it is not limited to Python. Also, there are interesting developments even with data, and some of you may have followed these like latest high performance libraries that are available now in the Python universe, things like Polars, things like DuckDB, that actually allow you to analyze pretty significant amounts of data, like even on a single instance. So like what used to be big data maybe just 5 years ago is not that big anymore. Which then like raises the question that, well, I mean, do you want to do all the data processing inside the data warehouse, kind of like a 1980s, 1990s style? Or like, is there a world like where you can use Snowflake as kind of like your master data repository? But I mean, let's say then like you have individual machine learning projects, individual AI pipelines, and like maybe it is beneficial that they can do their kind of like a last mile data processing closer to their applications, closer to that Python processing, and then use these high performance tools to analyze the data and process the data, do things like feature engineering and data pre-processing and so forth. So that would be another big motivation there. Now, the point number three here is that I'm sure that many of you who use Snowflake today oftentimes use it in conjunction with some kind of a workflow orchestrator. Like you may be using Airflow, maybe you orchestrate your data engineering pipelines using tools like Dagster, Prefect, Astronomer. There are, of course, like many options out there. And of course, like factually, like a Snowflake provides no support for this out of the box, I guess by design, and that's all good and fine. But it just like means that like you need some kind of like workflow orchestration outside Snowflake anyways. And then that like brings us to the question that, well, I mean, given that you're kind of working on workflows, you are building these data pipelines outside, like where do you exactly draw the line? Like why is it only the workflows? I mean, like also like should you consider like actually executing some of these steps outside as well? And now, like if you look at these three steps here, like being able to compute intensive, data intensive Python, and also like orchestrate like a more complex workflows, those are all like very, very common needs. But of course, the kind of a really like what is also like a very much like overreaching requirement always is that you have to do all of the above in a way that complies like with your existing security policies, with your existing data governance policies, which is to say that in most larger, more kind of, I guess, kind of a data sensitive organizations, you can't just willy-nilly do select star in your Snowflake and copy everything on your laptop and like kind of just like YOLO your way to kind of like in whatever environment. But I mean, there has to be some kind of a story how you maintain lineage, how you respect those policies, how like kind of like you work nicely with the existing permissioning that has been set up in Snowflake. So that is a big part of like what we are doing here. So this is not some kind of like a cool hacky way how you can just exfiltrate the data out and then like kind of you would be making many security people unhappy. But I mean the big reason like why we are doing things the way we are doing them, including the fact that we are running everything always on your account, is the fact that this is something that needs to work for banks, it needs to work for healthcare, it needs to work for any kind of operations that have to deal with compliance and like any kind of data privacy issues and so forth, without then like on the other hand like kind of making it too complicated. So if you happen to be in a situation that these are not top of mind concerns for you, you don't have to pay the tax. It doesn't mean that things have to be any harder for you. So hopefully like this is a bit of like a motivational pitch here, like why you should be following along. Now, okay, so like what are we going to do over the next about like a 40, 50 minutes here? So we will actually go through kind of a very practical examples, like how to make these things work. Hopefully kind of inspires you to think like kind of what is actually possible today. And we will first show like how you can actually like kind of do this secure integration like between Snowflake and a system like Outerbounds that then allows you to realize the benefits of like being able to run the workflows, compute, Python, all the good stuff, right? Then the second part is that, okay, so what is the actual experience for you as a data engineer, for you as a data scientist, for you as an AI developer, like when working with data from Snowflake, outside Snowflake? What are the benefits like you get doing that? Then the third one is that one thing that's super important here is that you know that there are all kinds of tools that allow you to, let's say, build dashboards and do some ad hoc data analysis using data like from Snowflake, let's say in a notebook or something like that. But the focus here is actually on building actual systems that run automatically. They don't require you to run the notebook. They don't require that you refresh your dashboards manually, but I mean, they run by themselves. And also like that they become reactive and real time in a sense that, let's say, look, whenever you get new data in Snowflake, these the data processing would happen automatically. So you basically start building this machinery that processes data on the fly, which is of course like what actually powers most of the businesses behind the scenes. Then we will touch the topic of compute, that should you want to do any kind of a more compute intensive processing as a part of your workflows, it might be model training, it might be model inference, it might be feature engineering, it might be, of course, like any kind of new AI use cases, maybe producing embeddings for your vector DB. I mean, the use cases are growing really, really fast for compute. Like how you actually do that, like without having to pay the Snowflake tax of like running everything inside. So we will talk about that. I mean, that's a very, very important topic, especially these days. Now, like as a very natural like a follow-up these days is that okay, I mean, what is the one of the most demanding compute heavy use cases today? It's of course AI in different forms. Of course, like we don't assume that most of you are like pre-training your own models or even fine-tuning the models, but it might be simple examples where maybe you call external endpoints, maybe you produce embeddings, like maybe you do some kind of a data processing or post-processing like as a part of your workflow. So like Eddie has really cool example showing how to make that happen. And then like hopefully like we have enough time to kind of pull everything together and then show that, well, I mean, these systems never exist in a vacuum. They are surrounded by ETL systems. You probably have other data engineering tools like dbt that you want to use. Also, like you want to eyeball, observe the results, maybe through interactive dashboards. How do you do that? And so forth. So like kind of let's hope that we have enough time to cover all those exciting cases here in the end. And I just put here like a QA in the end, but I mean it would be even more fun like if you can just put your questions on the fly on the Zoom chat. So don't hesitate to ask anything in the chat. So and hopefully like we get to answer your questions on the fly. Eddie, anything you want to add here, or should we just get started?
Yeah, I think let's get started. What are you
Yeah.
thinking should we go right into the dashboard for step number two?
Yeah, well, yeah, no, I can actually like give a sneak peek and maybe then yeah, I can show like maybe to motivate people to follow along, like a show like what we are trying to build here. And then like yeah, if you can edit then like show like how we can like get started with the point number one here.
Yeah.
But let me actually like really quickly show like kind of a what we are going after. So I know that like we will go much more into detail of what's happening here, but hopefully you can still see my screen. I'll show you here that let's see here. I can make this a bit bigger. That the idea basically is that let's say we want to start building these workflows that run automatically, as I mentioned. And the idea here is that like you would get your data from Snowflake. We have a flow that senses like whenever like a new data appears, we can talk how that works in practice. And then the idea is that you then, as you have that secure access to data, of course, you can start building all kinds of applications and workflows. Like you can do something compute intensive, like we will be talking about producing, let's say, weather forecasts on the fly, or then like you can just like do analytics. You can like observe like what's going on. Like for instance, like we have this cool visualization. I can just maybe quickly show you because it looks fun. So we have the weather visa flow, and let's take the latest one. This should have run like it's just some time ago. So yes, so I think this data updates every hour. So this is also like an important point here that like we can build things that run continuously. And like for instance here, let's see. So today is the 6th, and I think that like that is UTC time, so that should be like pretty recent. And this is actually like pulling the latest data now from weather data from a table in Snowflake. And like then like this, yeah, for those of you who recognize the area, it is the San Francisco Bay Area here. It is showing that it's actually pretty chilly here today. It's actually raining, so it's all blue. And basically, like what it's doing is that it's producing this beautiful visualization as a Metaflow card here on the fly, updating that every hour. So just to show that like what kind of things we are able to build like once the connection is in place. But yeah, no, I think like maybe we should start building to show how things work in practice. So Eddie, do you want to take over and like show how we can start connecting the pipes?
Yeah, let's get started. Okay, so I just sent a request to share my screen.
Yep,
There we go.
you can take over.
Right. And are you seeing the Outerbounds dashboard now?
Yep.
Okay, great. So I want to start off with kind of like the nuts and bolts of prior to all the kind of like the workflow orchestration and the visualizations and things that Vila was showing. Like, what are the kind of foundational elements So most of our customers will come to us and they already have a Snowflake database set up. They've already got their warehouses, users, roles, etc., ready to go. So one way you can get started on Outerbounds is we have this /learn tab that you can find in your Outerbounds deployment. And we're going to start off in these end-to-end examples, which will actually take you through different UI views that you can use to understand where you're going and get things set up within the product as well. So this one, getting started with Snowflake, what we're going to do is we're going to create what we call a resource integration. So we'll go to this integrations tab here on Outerbounds, and that's going to allow us to connect our Snowflake assets on that side. So the roles and the users specifically that are going to give us access to specific databases. So you might have an administrator on the Snowflake side who kind of sets up all these roles and gives the analysts, the data scientists access to different kind of corners of the Snowflake universe for your organization. So we're going to kind of see how you can connect all of that permissioning logic that's happening on the Snowflake side to run on Outerbounds. So I'll go ahead and click the Start Journey. If you're interested in this, you can also read these as public documentation. So I'll kind of skip through some of that. But this first view that we're looking at here is the Integrations tab. So you can see that we already have plenty of these integrations. Yeah, maybe do you want to say a few words kind of about like what is the scope of these integrations and like what do these different symbols mean on the left column?
Maybe if you scroll down, kind of contextualize this, that the
Yeah,
idea in all of these cases is that the point is to build systems that don't exist in a vacuum. And this is actually a big difference that we see between a platform like Outerbounds and then like of course like all kinds of data science environments that have existed like for the longest times that oftentimes were treated as a walled gardens. So you had all these systems where you put CSVs in and then you did some modeling inside the tool and then maybe CSVs came out and so forth. And it was more like a back office thing that like almost like a BI environment. And our philosophy and like a point for using a tool like Outerbounds is that you can actually like that becomes the platform and the foundation for building these live systems. And these live systems never exist in a vacuum. They always interact with like a different services around them. Like, of course, Snowflake is a great example of having an upstream data source. Like maybe that's where you push the results. But of course, there are many others. And like a good example are all these AI endpoints, like we have OpenAI, we have Anthropic, but also like infrastructure services here. We will talk more about the compute integrations, but then also like AWS services, like we have, of course, like S3, or like it might be Redshift, or like it might be SageMaker, or like kind of now things like Hugging Face, and maybe you want to track something in weights and biases. So the point is that like the platform, like kind of a instead of being an island like a walled garden, I mean, it is tightly integrated to everything around it. And like I guess Snowflake is the point of this talk, so we can talk about that.
cool. So yeah, I'm gonna go ahead and open up the form. So this is what it looked like when you come in here. I've already pre-filled this information, so don't want to be sharing our Snowflake account credentials on the live chat. But essentially, what you do is kind of take the normal account information that you have on Snowflake side. So every Snowflake account has a unique ID, and then kind of the Snowflake admins are typically constructing basically trees of these users and roles and granting them different privileges over tables, schemas, etc. inside of your Snowflake account.
And Eddie, I
So
mean,
yeah,
just to maybe, yeah, like just to make sure that like we get it right. So the idea is that these are existing Snowflake users and roles, so you don't have to do anything special here. So
right,
whatever
right.
users and roles you have, they should work.
Right. So we have a separate, like a whole separate piece of documentation that'll help you if you're like a brand new Snowflake account just spinning up your data platform. Kind of a separate use case though. Most of our customers come to us with like already having Snowflake assets like this.
Mhm.
So this is kind of the case where you might know how to do this, like plug it in with environment variables in your Jupyter notebook or something like this. And instead of kind of passing around the .env file or something that's kind of a less secure way to pass around database credentials, this is Outerbound solution for kind of how you would take those permission boundaries and plug them into Outerbound's use cases. So you'd fill in your user, your role, with warehouse databases and things like this. And this is going to automatically populate on the Python side. This is going to automatically populate what the Snowflake connector object needs in order to communicate back and forth between the Python runtime and your Snowflake assets.
Mhm.
The kind of important thing that Outerbounds is doing on this side is exposing this security integration, is the Snowflake terminology. Is there anything specific you wanted to mention about the security integration?
Yeah, no, I think that that's definitely like one of the key things here, like which is like worth emphasizing. But of course, the way how people have been connecting to databases for the last, I don't know, like 4 decades is that you have a password and then like, yeah, I mean, you share the password and of course now everybody tells you that, well, don't do that. Instead of maybe use some secret manager, which is, I mean, definitely way better. And like we even have that support. So if you want to use your secret manager, like you can that as well. But the beautiful thing here is that Snowflake has this feature called security integration that allows you to basically tell a Snowflake that I want to trust this external system with a very specific scope. And I think like one thing that's really like important here is that like maybe Eddie, if you just for fun, like you put some role there, I mean, just type something like a demo role
Yeah.
or something, right? We can just highlight like what happens. So now, like for instance, here you can see that there's the allowed roles list. They're like the capitals. And basically now, this is a piece of SQL that you would then execute on the Snowflake side that basically tells that like you also see this whole like OAuth thing there in the middle saying that this very specific outer bounds deployment that is specific to you has access to this specific role, to this specific user in this specific whatever, like a database and so forth. So also like what's really important here is that like you are not like granting the keys to the kingdom and like admin
Mhm.
like access to Snowflake, but I mean having a very tightly scoped role without having to worry about any passwords, like without having to worry about any password managers, but basically just telling Snowflake that okay, like kind of within these constraints we can trust this external system to access the data.
Yeah, I would almost go further and say that given like events of the last year, this is almost a prerequisite for using Snowflake with like a workflow orchestration solution like Metaflow, where
Mhm.
they pretty much kind of have a hard requirement on things like MFA if you're going to be using password-based auth, which obviously I don't want my DAGs running at midnight and then I have to wake up and hit yes on my iPhone or something for MFA is
Oh yeah.
probably not the way that you want to be interacting with your database in a production system.
Yeah. And
Um,
by the way, like John here mentioned in the comments that it's really nice to have the role and the scope specified. And yeah, I think like anybody who has built serious like let's say data engineering systems or like led an organization knows that yes, I mean you do want to scope these things tightly. Like we have customers who have even like multiple different teams who own different tables, maybe own different databases, and then yeah, I mean like they are only responsible for their own domain and nothing else, and that's how it should be.
right, right. So I've already kind of prepared some of these roles, specifically the NOAA weather one. I just want to use as a, kind of an introduction piece here. So I'm going to go ahead and I'll skip past this step, which is just about downloading some of this content. So you can download it either within Outer Bounds on a workstation, like you see me accessing here, or just kind of on whatever computer you want to access Outer Bounds from. But the actual like interesting piece of content now is to get into, okay, there's sort of two environments where you would want to do this on Outer Bounds. The first being a notebook. So when you're developing things. So I'll go ahead and import these two dependencies. The interesting bit here in relation to this resource integrations conversation is Metaflow has an internal way of connecting to Snowflake, where all I'm going to actually need to pass is my integration. So on that previous slide, we saw I had the secret integration for with my roles and everything set up on Snowflake called NOAA weather. And this is the only variable that Outer Bounds needs to know about essentially to kind of populate all of that information. And then in the normal way that you would use Snowflake in a Python environment, it's going to return that connection object um, only by passing the integration into this Snowflake constructor. So when I go ahead and do that, after I actually run the cell, it's going to be able to kind of run queries against my account. So I can see the role that I'm actually using on the Snowflake side that I filled in that form is called Eddie demo role. And now what I can do is start to actually interact with some tables. So inside of that database, I have a table named weather. Let's actually go into Snowflake just very quickly and see that. So inside of this NOAA database, in our public schema, there should be a table called weather. So this is the data that we're actually going to be pulling from. So we should get, the point is to basically, how do we pull this into our notebook, kind of the most vanilla use case for Snowflake EDA here. So I'll go
And
ahead and run
I guess
this.
just to kind of underline like what you had done, I guess like before here is that there was this create security integration. So you just need to copy paste that SQL
Yeah,
to Snowflake, and you execute that SQL once, and then that will basically create the secure integration, and that's the kind of a magic that makes everything happen here.
exactly, exactly. Actually, you know what? I wonder if I go back here, I think I can still access it after. Is that right?
Yeah, maybe. Yeah, I
Because you
think
can
it,
just rerun. It's like an idempotent SQL statement, so you can just rerun it and it'll work. But it looks like I
yeah.
have a different thing here, so I don't want to mess with that right now. It's a bit of a detour.
I think it's
Um,
smart enough to realize that you may want to change even the roles later, so it actually like
right.
alters. So yeah.
So yeah, so okay, so I've done this, and then basically this kind of next step here is now, people come to Outerbounds to run workflows. So we have this parity between notebooks and workflows is really convenient for making your development environment consistent, your debugging environment consistent with kind of a dev staging prod for your machine learning workflows and AI workflows. So now moving into kind of using Metaflow as a workflow solution, we have the same exact code. So we have our integration here specified as we did on the resource integration side in Outerbounds UI. And then we have the same exact query. Let me move my Zoom windows around here. And I'll go ahead and copy this command, which is how we're going to run the workflow. So when I open up a terminal and do Python, and then the name of the file is flow.py, and then we'll go ahead and run it.
And maybe like a for like a those of you who might be new to Metaflow, so Metaflow is an open source project that we studied at Netflix before starting Out of Bounds. And you can actually like go to metaflow.org, like find all the details about, let's say, the workflow structure here that Eddie is showing. Like we have this flow, a workflow, hello Snowflake flow, and it has a start step, which I guess Eddie is now running here.
Mhm.
And yeah, so there's plenty of stuff. I mean, the whole point of Metaflow is that it provides you a full stack of infrastructure, full stack of software that allows you to run workflows, access compute, do versioning, and so forth. So plenty of functionality there. And today we are really focusing on this data part. But I mean, definitely, if you are new to Metaflow, take a look at metaflow.org and read all the features that are available.
Mm-hmm. Now let's spend like maybe 30 more seconds, and then we can move on to the sensor flow because this is obviously just the hello world. But sort of like the interesting bit to think about here now is like, okay, sure, everyone's seen you can pull data from a warehouse into a notebook. Probably most of us that are like doing machine learning engineering have seen you can do this from a workflow system. One interesting kind of convenience thing that Metaflow provides is this artifact, being able to pass artifacts in between the different steps you run. So if you're familiar with different compute platforms, the one that Outer Bounds uses is Kubernetes. So the different steps that I'm running in this workflow are running in completely different Kubernetes pods in the cloud. And what this artifact mechanism is doing is I'm basically taking that query. So I'm kind of pulling like a small subset of my data out of the warehouse, doing a little processing with it in Python. Like here, I'm not doing anything interesting. Again, just hello world example. But we'll get into like what kind of use cases are interesting for doing this later. But I'm saving this variable using Metaflow's versioning, and Metaflow takes care of packaging all of this up so that in the completely other Kubernetes pod in a different step, I can access that same data frame that I pulled out of my Snowflake warehouse. So we'll see once this end step gets going here
I
that
guess you
that'll
can
just kind of print out how
maybe
many
show the
rows we
UI,
fetched. Yeah,
like
good
the
point. So here, the Metaflow CLI has this nice kind of functionality to open up the UI. So you can kind of see the timeline of our runs.
maybe you can
And these
show
are
the
the two
DAG
steps as we
here.
saw. Mhm.
Yeah, so we have the two steps that we define in the code, and basically now, I mean, just to like if you are new to Metaflow, now what's happening here is that we have this workflow, which is kind of like, let's say, if you have used other orchestrator like Airflow before, so you can consider this like Airflow DAG. Uh, but the like, well, I mean, it's a whole another topic, like what are the differences between Metaflow and Airflow? But I mean, basically now, like we are able to construct these workflows really easily. And then like one big benefit of Metaflow is that what Eddie was showing here before is that you can also test the workflows really easily. So like not only deploy them to production, and um, and then like the compute would be the other big part that we can dive deeper later. And yeah, so now we basically have this whole workflow securely connected to Snowflake. And what's happening here behind the scenes, which is exactly by design, it kind of almost like doesn't seem like anything, is that the thanks to the security integration that we created earlier, now like everything in the platform basically derives and inherits those integrations, so that now like whether you are using a notebook or like whether you are running this workflow, like everybody has consistent access to the data warehouse. So this is also like one thing that we have noticed, like working with many folks that I mean, they may have some kind of a notebook test environment, and then they maybe set up a IAM policy there. But then when they try to deploy something in production, then suddenly they need different IAM policies, and the database access doesn't work anymore, and it works one way in production and like one way in the development. So the key thing here is that like we now like through making that one simple integration, like we have a consistent access in all these environments. And the whole point is that you should be able to kind of test these things really quickly locally and then push them to production really fast, like without ever like ending up in a situation that, oh, like something works on my local notebook or something works on my local machine, but then it doesn't work in production, or vice versa, that like the production system can access the data, but then if something fails and I need to debug it locally, I mean, nothing works anymore.
Pardon my short-term memory, but do we have space to talk about perimeters lately and like kind of extending that idea into kind of the side-by-side deployments concepts? Or
Yeah.
is it a good time now
I
to
think,
go
well,
into
I
that?
mean, yeah, I think that's a great point that you mentioned. I mean, yeah, maybe like, yeah, we can linger like a few minutes on that topic.
Yeah, so like I think that that's a really interesting kind of pattern that you're mentioning, this sort of like different like a lot of database providers actually now too, like especially these like serverless database providers kind of also have this concept that's like similar to maybe Vercel if you're into front end development, where you can kind of quickly like have these different branches and sort of CI/CD is just kind of baked into all of these more like SaaS user experiences. Um, so kind of going, did somebody have a question?
I think that there was,
Maybe just some
yeah.
feedback. But anyway, so perimeters is a solution on the Outerbound side that kind of provides something similar where you can sort of have these maybe side-by-side deployments, and within each perimeter, you might want to set up unique resource integrations. So if you have kind of a dev staging prod set up on your Snowflake warehouses, databases, etc., you can then kind of create these resource integrations and scope them in outer bounds and kind of map that whole system into kind of the same branching mechanisms. Is there anything further or kind of deeper that you'd want to say
Yeah, but
on this
exactly.
page?
Yeah, no, I think that that's the key thing, and definitely maybe something that again, I mean, deserves another like webinar is that how do you set up these different experimentation, development, staging environments. But we work with many companies who, for instance, like have to be pretty strict about exposing only some, let's say, test data sets or anonymized data sets for testing. So like when, let's say, data scientists, ML/AI developers are developing their solutions, they can only access a subset of data or like maybe kind of a filtered data. And that would be the experimentation environment that has a certain access to Snowflake. So you develop your code like with that kind of test data set. But then like when maybe we can quickly touch the topic of CI/CD as well, then like you like deploy these things to production, and now without changing anything in the code, you just have basically like a different integration on the production side that then grants the workflow access to, let's say, a larger data set or the actual production data set. And like the key thing is that like you don't have to change policies, you don't have to change anything in the code, especially like you don't have to have any conditionals in the code that, oh, like if we are in development, do this, and if we are in production, do that. So I mean, those are the things that like typically then like a cause friction as you are trying to get to production as fast as possible.
Sure. I see I've already went way far on this first section, so maybe we should keep moving.
Yeah, good point. And I guess like a John here, like for this who might not know or be as familiar with Outerbounds, can you explain how the school notebook environment is working within the Outerbounds UI? I think that's a good call out. So Eddie, do you want to quickly talk about that?
Yeah. So we call this workstations in Outer Bounds. So workstations are kind of maybe analogous to like a Google Colab notebook, which pretty much everyone's familiar with. Um, Except they're sort of full development environments. They're unique Kubernetes pods. You can do everything you need to do on Outer Bounds from your workstation, and it's going to already be authenticated to kind of do everything that you'd want to do. Um, the specific part about the Outerbounds UI that John mentions is that you can also run these workstations with a UI view inside of a browser tab, essentially. So you don't need VS Code on your computer or Cursor or whatever IDE that you might want to access the workstation from. You can just do that directly from your browser.
Right. So hopefully you can see my screen. And like, for instance, here, I have a bunch of workstations that have been configured to me. And again, by the way, like one thing here, which is like people always ask that, okay, how is this different than something like Google Colab or GitHub Code Spaces and so forth? One key thing is that everything that you see here, everything that we show in this demo always runs in your account. So it's not that you are using some other other like a third party service like for this. And like this is of course, especially in the context of data, super important because it also means that all the data processing, all the development happens within your kind of like a cloud prem environment. So these workstations are just part of your environment. But also like one thing that's good to highlight is that it's by no means limited to do like doing things in browser. So of course these days actually like many people like want to use quote unquote the proper IDE. So let's say I have my local VS Code here. I can connect to the local VS Code locally as well. So if I just want to use an IDE here, I could do that equally well. So we have this VS Code extension. So, but I mean, just like for demo purposes, it's actually super convenient to do things here in the browser. So I can keep doing that. But yeah, it's a good question. And by the way, like you could totally like do everything like outside this environment as well. Like actually, that's another key part of the security integrations as well. Like maybe I'll just super quickly show you this one picture here that if you wanted to develop your like a project, let's say on your local laptop, or like even you have your like a favorite notebook environment, you could do that, or like you can use the kind of the VS Code environment. They all like work exactly equally when it comes to the Snowflake integration. So it is not somehow that like as long as you stay inside some kind of a walled garden, things work, and then like you're out of luck, like when you go to your own favorite environment. So even if you are Emacs user, even if you use Vim, even if you want to use whatever like a Raspberry Pi to develop your code. I mean, it actually like the amazing part is that it works. It's also like connected to your SSO. It has all the security features. So that's actually like one of my favorite things that like when I'm like developing this way, I kind of feel that I'm fully empowered as a software engineer also, which is becoming increasingly important because AI is not like some back office activity. And that's a big difference also like to many of the existing tools where like kind of the idea is that you are like a bit more constrained to the environment.
Vile, we have another great question here to linger
Yeah.
on the CI/CD conversation. Can the environment be linked to a Git branch, master branch for production, for example? Does
Yeah.
promotion from lower environment to production work from the UI only, or can it be integrated with some action, like such as a merge to master?
That's an excellent question. And so Eddie, by the way, are you still like seeing my VS Code here or like the browser window?
Yeah, I see the in-browser
Yeah,
view.
cool. So cool. Like let's kind of answer that question instead of like telling I can actually show. So
Nice.
let me actually like before answering that question, like take a one step back. So what Eddie was showing there before is like showing how we can connect these workflows to Snowflake. And now, like what I hinted earlier, like when we studied that we can actually start building these like a more complex workflows that also like react to new data appearing like in Snowflake. So maybe I like just like spend like 1 minute in talking that okay, like how do we actually even know like when new data appears in Snowflake? So let's see here if I can like pull you like this one slide here. So now, I'm sure that like all of you, you have your own ways of actually like populating data inside Snowflake and ingesting data there, and hence like we have a couple of different patterns here, as highlighted here in this slide, how you can actually capture those change events, like whenever something changes in Snowflake that should then trigger some downstream action. And that kind of depends like how you have set up things on the Snowflake side. So here is the kind of a one option A is that some of you may know that Snowflake has this relatively new feature called like they have this like a data streams inside Snowflake, like where you can kind of capture the change metadata and then like you can actually launch any Snowflake tasks like based on these like changes. And now like we do support this idea of having a small stored procedure on the Snowflake side that then can create an event on the Outerbound side, basically saying that, okay, I mean, like you can have whatever logic you want inside Snowflake, you can define it all using all the Snowflake features, and then say that, okay, I mean, now the state of the tables is such that we want to trigger actions outside. So that is one option. That is option A, right? Now, the other option that like some people prefer is that like when anyways, most likely like you have some kind of a ELT or ETL running against your Snowflake. So maybe you have, and we can actually talk more about it, let's say using dbt for this, that you run your like ETL pipeline. And then like at the end of the ETL pipeline, then you can like trigger the sort procedure and say that, okay, the ETL is finished, the tables have been updated, and now like let's create that event. So like a small variation of the option A here, but I mean, you don't have to deal with any kind of like a change streaming kind of a tables there. So it has these pros and cons. Now, of course, like one idea is that, let's say if you have your existing systems, like if you use Airflow on the data engineering side, then of course, by all means, like you can create those events, like let's say on the Airflow side, it can be kind of outside Snowflake as well. But then like also like one like a super simple approach that kind of always works is that instead of doing anything or changing anything inside Snowflake or inside your existing ETL, you just keep an eye on the Snowflake tables and see when things change, then you can trigger these events. And given that this option D, although it is kind of like a rudimentary and simple, I mean, it kind of always works. And the nice thing about that is that it doesn't require any changes to anything that you have already done. So even if you don't have a good relationship with your data engineering partners, they don't want to change their ETL, I mean, you can always do this. So like let's like dive a bit more into detail, like how this option D works here. And yes, it
SD
is a
data engineers.
yes. And like I will get back to the CI/CD question as well, so don't worry. So one thing that I do want to highlight is that we actually now have this repo. It's a public, actually a template repo called Flow Project that then like makes it very easy to create pipelines like this. Like for instance, we can simply define that like how often like we want to check the status of the table. And like here, for instance, we could say that like every half an hour, like we want to see if anything has changed on the Snowflake side, or could be anything here. Now you can imagine that this is not exactly suitable for like a super low latency processing. So if you need to get those triggers, let's say like with the 1 second latency or like even sub-second latency, I mean, then definitely you should do the processing inside Snowflake so that you don't have to pull the database. But I mean, realistically, most batch pipelines that let's say like run once an hour or like once a day, I mean, this is perfectly adequate. And then again, like you put the same integration name here that Eddie showed before. And then like there are a couple of options here, but I mean, you don't necessarily have to worry about it. So I can show how that works. So let me actually go back here. And I have configured here, I have this weather example and I have this flow project here. Again, like we are like looking at the weather data and looking when the data changes. And I can actually, as I mentioned, like one of the big benefits of Metaflow is that it makes very easy to test these things locally. So I can even take this sensor flow and I can run it here. We can actually like look at the code. I mean, it's like a really nothing too special, but it actually now like connects to the Snowflake database and sees how the values have changed. So I can actually like here in the UI, like I see that as well. And the let's see, like kind of when we get this card here. So like let's see, like oh, I should have mentioned that. Of course, the big part is that like how do we know like what are we interested in? So we define basically this simple piece of SQL here. Let's see if we can like see this. Hopefully, that basically looks at the maximum available timestamp in our historical weather table, and basically like whenever like the maximum timestamp that like a high watermark changes, then we know that okay, now we have a new forecast available, and then like we can kind of update our stuff. So this is what we want to run against the database. And then like we're basically keeping an eye on that timestamp. And like here we can, for instance, see that the value changed. And of course, like one like a small detail which is worth highlighting here is that of course because it does remember the old value, and I can actually like run it again here, it kind of implies that it has to remember the state. It has to remember like kind of what was the value before. And now there's the interesting question that like how does it actually remember that value? And like that actually is done like through Metaflow artifacts, because Metaflow has this mechanism of storing the state and storing the values. It actually like piggybacks on that mechanism because it's also super scalable. And I can actually like show you here in the code, hopefully, like I can. So where is our previous value? So here, um, we are actually like looking like at the not the latest execution because that's the one that we are currently running here in the sensor flow, but the one before. So when we instantiate this flow object, like for the sensor flow, we can basically go back in time and say that okay, what was the value of the timestamp in the execution that we did before the current execution? And we can basically like almost have a time machine and go back, and then we basically compare that has the value changed. And then like actually like this is like it looks ugly, but it's not an error. It just says that okay, now we notice that the value hasn't changed, so it basically gives up and says that okay, I mean no need to continue, and like we don't have to trigger anything downstream. So now like yeah, was there a question?
Yeah, I was going to say like what I think that's a really powerful pattern, and I was curious if there's any other kind of use cases for this that stick out in your mind. This kind of notion of like you have like the full flexibility of writing Python code to kind of check for any way that you want to look at a diff in the moving parts of a machine learning system is like a massively important thing for debugging production ML systems, in my view. But I was just
Exactly.
curious, like if you have other kind of like just kind of paint more colors on that idea.
Yeah, totally. And actually this is such a kind of key building block like for many practical systems. Like we have one customer who has this service like where you can upload videos and I guess the videos get uploaded in some S3 bucket. And then like when you get the videos, then they want to run some analysis, like whatever fancy AI stuff on the videos. And now like kind of the same idea that you keep an eye on the bucket. Again, I mean the same applies that you could have this use the S3 events and like create an event like every time you get the new object, or like you can just like observe the changes in that bucket. So that would be one case. Now another like a really like a down the road like a fancier case is that as we saw here that then like you can actually create these connections between these flows. And now let's say like we have this sensor flow, but I mean then we have let's say the visualization that we saw before, but let's say like we have a forecast that we want to create here. So like what we do here is that we have this like a trigger on finish, and we say that whenever now the sensor flow finishes like with the new value, then we want to create a new weather forecast. So we can start composing these larger systems out of these interconnected pieces. And now you can imagine that in a larger organizations, it can be even different teams that are responsible. Maybe we have one team that's responsible for the forecast, one team that's responsible for, let's say, the ETL part, one team that like kind of is responsible for maintaining the data quality, whatever it might be. And they all like get neatly connected through these events. So that's a super powerful pattern. So like maybe I'll like quickly show you like because now we are getting to the compute point as well that okay, let's say that like this far we have been just like getting data out of Snowflake, so that works. But I mean, let's say we actually want to do something interesting with the data. So let me show you here. So we have this super simple forecast flow that actually looks at the historical weather and then produces forecasts based on that. And we are using just the SK time. It's like a time series forecasting library. And what I can show you here, is that like let's like in the interest of time, like I show how it works that we can basically take any previous execution like of that essential flow and then like trigger this thing. And I'm just like showing this like again to highlight the fact how easy it is to test these things locally. Because again, I mean, this is an example that okay, I could of course like deploy this to production and then wait for an hour and then hope that like something happens. But of course, I just want to develop quickly, so I'm taking like a previous event and like seeing how things work. So now here, like when it's running, it's actually like using that SK time library. And by the way, like you may wonder that, okay, how did we even like get that library running on a remote system? So we actually like package everything, create a container automatically. So that's again like a topic for another one. And now like what's happening here behind the scenes is that it's actually like now like basically creating a separate forecast for every zip code. So there are like a bunch of zip codes, like a 1300. So you can imagine that, of course, like if we had a fancier model, if we had like all the zip codes in the US, that would take way longer. And most likely we would actually like want to parallelize that even to more instances. So it might be that we are actually in this case like factually like producing a like a 1300 separate model. So it could be tens of thousands of models. So that is like a decently compute hungry activity. And this is exactly the type of thing like where you want to have that kind of a compute platform that gives you the hardware resources without breaking the bank. So now, like in this case, like we can actually like I quickly go back here, like show that actually the result of this thing is that like we are producing the forecasts here, like we are like kind of we show the progress bar here. And let's go like back here. So let's see if we have then the final results. Like we had just like a sanity checking kind of a one zip code to see like if things make any sense. I think that this is somewhere in Boston. And this actually the blue line here like shows this is just like over the past like a few days, like how the weather has been. And then like this is like just like our like a silly forecast. I mean, now of course, like if you have any actual like people dealing with the weather, I mean, like you would know that this is of course not the actual way how you do weather forecasts, but actually like in certain places it works surprisingly well. So we are like predicting that for the next 72 hours, I think. But like just to linger on the topic of compute a bit more. So let's say that you had an actual like a fancy model. I think that they even are starting to have some foundation models for weather forecasting. So and like you needed more compute power. So actually, what's happening here behind the scenes is that Outerbounds is now connected to your cloud account, in this case, AWS. And like we can then define any number of compute pools. Let's say we needed GPUs, like we could say that, okay, let's use P3 2x large instances, or maybe we need like whatever, like a lot of memory, like kind of, and like here's like 128 gigs of RAM that we need on the kind of M5 2x large instances. And we can basically configure our compute environment however we want. And now the key thing here, and like if you consider, let's say that if you ask Snowflake, of course, they would say that, well, I mean, you can use Snowpark, like you can run this code inside Snowflake as well. And certainly you can. And they would be actually launching the very same instances behind the scenes because it runs still on AWS, but they would be slapping the kind of the high margin on top of that. So it would be a very expensive way to run exactly the same Python code. And this is something that's always so puzzling that at the end of the day, I mean, this is your code. This is your modeling code. This is your data processing code. I mean, like a Snowflake, I mean, it doesn't like change it in any way. Like we don't change it anyway. So the question is that like, what is the most cost-effective way to run this very code? And now the most cost-effective way is oftentimes that you just take the bare bones EC2 instances, or you can even take spot instances. Or like what you can do is that let's say you need GPUs, you can even go to different vendors. Like maybe instead of like using AWS, maybe you go to Azure, like maybe you go to GCP, maybe you go to some of these specialized vendors like CoreWeave or like directly to NVIDIA's cloud and get the resources you need without paying any middleman anything extra. And like again, like what we do here as Outerbounds is that we are not adding any additional cost. Our business is not to resell the compute. Our business is to make it this easy for you to kind of build these applications, right? I realized that like we are like kind of like running short on time here, so I guess we can just quickly speed run like the rest of the topics here. I do want to quickly get back to the CI/CD topic here. Maybe I can quickly show you. So let's say here that I'm in this project here. Let's say I do some like absolutely silly change, like maybe the time window is 10 days. Maybe we change that. And like, let's see if we can capture the change. So like we have a git diff here. And I'm currently operating in the main branch. So let's do a new branch. Let's say like kind of a better time window branch here. So like now we are in this branch and like let's make a change to the forecast flow here and say that like, okay, change time window here. And now like when we push this to a new branch on the GitHub, on the GitHub side. So this is exactly what you would do, the usual like GitOps flow here. And let's see here. Hopefully I have my credentials set up correctly. Yep. So now it ended up here. Let's see here. We can, sorry, I'm not, maybe I'll like use my other window. I think I'm already logged in there here. Okay, so we have this like a better time window and like we can even create pull request here. And now like the key thing, what's happening is that now we have this GitHub Actions hooked up here. And I can actually go here and like see what's going on. And this is the really the key part and like to answer the question that, okay, like how do we do different branches? So now it is actually triggering the GitHub action to deploy the workflows. It is actually like deploying a separate branch of this deployment. It's not like it's just blindly overriding the production, but it is like basically taking everything that we built and like creating a new branch deployment. What's also super cool here is that you can see that it's now baking the Docker images on the fly. And it honestly, like it's just magical that it happens so fast. It takes like 1 second to create those images. And now, like if we go here to this side, we can actually see that we have this whole deployment here under this better time window. And we have a whole like a shadow deployment of the whole enchilada, like where I just like changed that one variable. And you can imagine now being an data engineer or like being an ML or AI developer, and you had this idea that, okay, let's change the time window. But I don't dare, of course, I mean, like the worst idea would be to overwrite the production. What I want to do instead is to create my own isolated deployment like I did here. So I can test these changes and like I could change anything. I can change the model. I can like add some AI here, whatever it might be. And now I'm like operating in my isolated environment, like without stepping on anybody's toes. And then over time, I can see if this actually improves the results. And if so, then I will actually merge and like promote this to production. So anyway, so this is the way how you can work with branches. Now, I know that like Eddie, we don't have too much time, but I mean, do you want to spend just a few minutes on the question of AI? Because I think that that's the one topic that we don't want to miss, I guess, like it being 2025.
Yeah, definitely. Yeah, so I mean, I think you made a great point. Like, maybe we should just do a discussion instead of go through code examples. We can do like a whole separate webinar maybe for the code samples. Um, but I suppose like what I was thinking of as the segue from what the previous section is, you mentioned the cost effectiveness is kind of one reason. Like you don't want to be kind of paying margin for other people's business to run Python functions in the cloud, essentially. I think there's like other benefits that are really relevant in the AI case that people are thinking about. Kind of the two main ones that pop in my mind are like flexibility, kind of like preserving the option to use different vendors, say like maybe I want to be testing with OpenAI in my development environment and then kind of quickly move to some self-hosted Olama model or something like this.
Mhm.
Um, it's harder and harder to do that if other people are controlling your infrastructure more and more.
Right.
In a multi-tenant architecture where I just kind of like lob a job definition over to somebody else, it's much harder to actually like kind of control that system typically than it is if it's running in my AWS account. So you kind of get maybe a little bit more upfront cost to set up that system, but the kind of optionality you preserve mixed with kind of the long-term kind of steady state cost benefits that you mentioned earlier is really huge for kind of maintaining that ability to choose essentially down the road. And
Exactly.
then
Yeah.
kind of related to that as well, it comes back to data security, I think, is those choices enable you to kind of pick how to store the data on the instances, how to move it around within your own cloud account, and kind
Yeah.
of not have to necessarily sort of pass on the descriptions of security from the vendors you use back to your customers and so on and so forth.
Yeah, no, I think
Um,
that's super important. I guess like everybody saw this happening with DeepSeek, and now I mean there's this like a constant catching up that everybody has to do. That I think it took a few days for Snowflake say that, oh look, now we have DeepSeek as a part of like Cortex or like whatever. But I mean
mhm,
I think it like in the long term it is absolutely like unsustainable that like this is such a kind of sprawling field and the things are moving so fast that like you could imagine that any single vendor could support like everything under the sun. So I mean, it's just becoming more and more untenable. Combined with the fact that like increasingly companies do want to actually do some like a customization. I mean, like not many do fine tuning today, but I mean, we have customers doing fine tuning, and then like they may have a very specific ways of doing this. And again, I mean, then it becomes increasingly hard, like kind of for you to kind of just get everything working inside a more limited environment. So our especially like at times like this, I mean, having the flexibility of being to your point, Eddie, to be able to use any vendors, to be able to also own the parts that you want to own, like fully in your own environment. It's really, really so important.
mhm. And I guess just to show something really briefly, like I won't run the workflow today, but kind of like one reason why I like thinking about like the workflow orchestration systems is kind of like the place that a lot of these decisions emanate from. Is like if you look at how Metaflow code would work, like this processing step, say in this workflow, like what we're doing is pulling a bunch of data from Snowflake, and then for each row in the table, we have some processing task that like the LLM reads a bunch of stuff from their website or something, and then spits out an answer about things. So like say like right now I'm using OpenAI, and all I do is just kind of install the package, and then Outerbounds is a secret provider, so it works very similar to the Snowflake case where I just kind of plug in my OpenAI key on Outerbounds, and it manages the secrets for me and populates it in the runtime. Now, say I wanted to then kind of turn around and run on my own GPUs that maybe I have them sitting under my desk, or in our cloud account, we have GPU quotas. You kind of could just take away the secrets. You don't really need OpenAI anymore. You might instead install transformers here. And then when in Kubernetes, you say GPU equals one or something like this. And that's pretty much it. You can very quickly like kind of build these code bases where you can kind of have that optionality where I don't have to think about how to implement any of this stuff if I just want to run a quick A/B experiment of those two setups. Um,
Exactly. And I think like one another thing that's hugely important to highlight here is that of course like let's say you use any other workflow orchestrator. I mean like the workflow is the same, but then there's like exactly what you did there. I mean you just like I said, oh like give me like one GPU. Maybe you need
mhm,
like I mean honestly like you could even have a cluster of like a GPUs. I mean like you can do distributed fine tuning of the like biggest models and suddenly maybe you need a big bunch of GPUs. And that's again like where the question of compute comes in that okay I mean like well we don't want to do that inside Snowflake, we can't even do distributed training inside Snowflake anyways. And then yes I mean we could have any workflow orchestrator but it doesn't solve compute. And then there's a big question that okay like how do we find those resources, and then like how do we get the data onto those boxes, how do we get
mhm,
dependencies onto those boxes so that like we can actually like do exactly the thing that you did there. And this is exactly the point where most organizations just like throw their hands up and say that like well I mean that would be way too hard. so we can't do it, so let's not do it at all. And especially like at times like this when things are moving so fast. Again, you just need the flexibility of being able to kind of test things like when it makes sense. Again, you could take exactly what you did there with transformers, like a deploy it as a branch deployment, and then like yeah, instead of like arguing that, oh,
Exactly.
like should you use a custom model, or like does fine tuning, is it better than prompt engineering? Like no need to talk about it. Just do it. Just do it
Right.
and like
Yeah. It just
deploy
kind
it
of
from the
becomes an
side. And
afternoon project. Yeah. And you can
exactly.
just get the answer. Yeah.
Yeah.
Um, so that was pretty much my main thoughts on compute. And like the demo I was going to show was basically just going to speed to that punchline. But I know we also had ETL on the agenda. Do you think we have time to go
I
there?
know,
Or?
I know. Like, I think we have to leave it for the next one. I think it's such a deep
Okay.
topic. I know that like we have many experienced data engineers, data engineer leaders in the call. So I think
Yeah.
it wouldn't do justice to try to squeeze it in 1 minute.
Yeah.
I know we
That
are
one I
over
don't know how
time,
to
so
speed run.
exactly, exactly. We shouldn't. So like we have to do another one of these. So thank you everybody for staying with us. Like we will make the recording available again. The blog article is available, the code is available. Of course, like goes without saying that like if you want to get started, super easy to get started. Always like you get the free trial. So just go to the website, click get started, and like we are happy to help you to test these things in your own environment without any commitments upfront. So that should be fun. And yeah, and well, many more topics to cover in the future. We definitely should dive deeper into the AI questions, like should dive deeper into data engineering. Of course, like we only scratched the surface of like even like building these workflows. So, but yeah, hopefully this gave you an idea like how you can at least like connect to Snowflake, do the processing, get access to compute, and yeah, more to come.
Thanks, everyone.
Awesome. See you next time. Thanks.